Welcome back. This is the linear and angular speed questions from the Unit 4 quiz that we took a couple weeks ago. So a pickup truck is fitted with new tires which have a diameter of 45 inches. How fast will the pickup truck be moving when the wheels are rotating at 390 revolutions per minute? Round your answer to the nearest whole mile per hour. So the big hint here is that it's miles per hour. So we need to convert whatever we have into miles per hour. So linear speed is just what we would expect any regular speed to be. It would be a distance divided by some time. In this case, the distance is an arc length divided by hours, something that we can convert to hours. And we know that the arc length is the radius times some angle that we rotate. Okay? So we know the radius. The radius is half of the diameter, so it's 45 over 2. Which is 22.5 inches. And the angle they're going is 1 revolution is 2 pi radians. But we can do 390 of those in 1 minute. So it's 2 pi times 390 . That's 780 pi radians total that we travel. So my linear speed is 22.5 inches times 780 pi radians divided by, that's going to be 1 minute. So when I multiply this out, I get 780 times 22.5 times pi, and I get 55,135 inches per minute. But we don't want to be in inches per minute, we want to be in miles per hour, so we have to do some conversions. So I'm going to do a couple conversions. First of all, we know that when we convert, we want to get rid of the unit by putting it on the bottom, or by canceling it out, essentially. So I know that there are 12 inches in 1 foot, and there are 5,280 feet in 1 mile. So by doing these canceling out, this conversion, I'm going to be left with miles per minute. But I don't want to have minutes. I want to multiply that by something to get rid of my minutes. And we know the conversion for minutes. 1 hour is 60 minutes. So we can see that we have all of our units canceled out. Inches cancel with the inches, feet with feet. Miles, we're left with minutes, cancel with minutes, and we're left with hours. So when we look at this, we have miles per hour, and we're all done. So all I have to do is multiply our numbers together. So I have 55,135 times 60 over 12 times 5,280. And if we put that in the calculator, we get 52.21 miles per hour. So when we look at the correct answer, it says round to the nearest whole mile per hour. 52.21 is going to round to 52 miles per hour. So that's linear speed. Moving on to number 12. The circular blade on a saw has a diameter of 7.25 inches and rotates at 4,800 revolutions per minute. Find the angular speed of the blade in radians per second. So we're probably going to have to do another conversion because we're in revolutions per minute and we want radians per second. So this one, angular speed, we talked about in class, was some central angle theta over some time. That's all it was. So we need to find the angle that we rotate and figure out how long it took us to do that. Okay. So we know how long it took us to do that. It took us 1 minute to go 4,800 revolutions. Well, how long is a revolution? On a circle, a revolution is always going to be 2 pi radians. We know the time it took was 1 minute, and we were able to do 4,800 revolutions in that 1 minute. So this 7.25 inches matters not at all to us in this case, okay? Because all we care about is the angle and the time, which we have those two things, or at least we can find these two things. So for our problem, let's go ahead and look at our angle that we rotate. So we had 4,800 revolutions times 2 pi radians per revolution, and our time was 1 minute, but we can kind of cheat because we know that we want to be in seconds anyway. So I'm just going to go ahead and say our time is 60 seconds. So all we have to do is a little bit of division. So 4,800 times 2 pi is going to give me 30,159.3, that's radians, per 60 seconds. So just need to divide those numbers. And my angular speed, which we didn't talk about this in class, but angular speed, we use that to represent it. So we're going to divide by 60, and we get 502.7 radians per second. And then I look at my answers and I realize that my answer still had a pi in it. So I need to go back up to this step and leave the pi in here. So it's 4,800 times 2 divided by 60. So it's 4,800 times 2 pi over 60 gives me 9,600 pi over 60, which is 160 pi radians per second, which is answer B. And that's going to be it for the 2 quiz questions.